Welcome once again to SBT 408 Toxicology. We are continuing today to look at some core concepts of the field of toxicology. And we'll begin by looking at the common term, poison. The term is a common word which is used in everyday language, not only by toxicologists, but even lay persons make use of this word, poison, which is sort of a common word referring to harmful substances. And I mean, one of the pioneers that we talked about in our last lecture, Orfila, who developed the methods for the determination of arsenic in, say, autopsy samples, exhumed bodies, and things like that. Actually defined poison as any substance that when it is taken in, even in small doses, such a substance will have some impairment to health or can result to death. But if we bring it in modern terms, in our modern understanding with the technologies that we have and the much more understanding of the field, then the use of the word poison to refer to substances that are harmful, can suggest that we have, say, two types of substances. To say that we have poisons and then non-poisons. That will be such a kind of a binary distinction between substances. But even from Paracelsus, what one of the things we studied in our last lecture, we got to know that any substance can be toxic under specific conditions, and that it is the dose of a substance that will determine whether the substance is toxic or not. Which means that there is a limitation to the use of this word poison to mean that a poison is a substance that has some harmful effect for biological systems, and non-poisons are substances that will have no toxic effect. Because now the understanding will be that even what it is that you are referring to as a non-poison, perhaps it is because of the amount of it which is being taken in, which is not causing it to express its toxic effect. But if you should take an amount which is above that, you may see that there is a toxic effect also of such a substance. Now, another word that we came across the last time, I think even from the very first lecture, toxins, which we did see that these were harmful substances coming from natural sources, plant sources, microbial sources, animal sources. We did see a lot of these toxins, examples of them from snakes, from frogs, from birds, spiders. We saw a lot of this. So toxins actually refer to substances that are from these natural origins of living systems. Even though the word is also misused a lot of times, if you go onto some of these websites that are promoting some of these alternative medicine, particularly making some unsubstantiated claims of cleansing of the body and things like that, they do make use of the word toxin a lot, but a lot of times such words which they use, the word toxin actually, they're referring to a whole lot of substances, But now you are becoming an expert in toxicology. You make use of the word properly. Toxin refers to harmful substances that are produced by living organisms. So like microorganisms, plants, animals. That is the substances that we do refer to as toxins. Of course, so this excludes synthetic substances like some of these industrial chemicals or some drugs that also have some harmful effects. Those are excluded from this term toxin because they are not coming from living organisms, but they are synthetically made. And this brings us to what we refer to as xenobiotics. Another term we come across is xenobiotics, coming from the Greek word xenos, which means, substance that's, xenos simply means foreign, something which is coming from an external source. And xenobiotics refers to substances that are entering the body from an external source or a foreign source. These are xenobiotics. And these usually in toxicology, when we do say xenobiotics, we are referring to either synthetic or naturally occurring chemicals. So either we are talking about some drugs, so that is some medications, can be some pollutants, some pesticides, even food additives, which will come from natural sources. These are xenobiotics because they are from external sources that are being taken into the body. Now, what would be the opposite of endobiotics? Xenobiotics. So that is endobiotics, which means that substances that are internally produced. So for instance, you have metabolic processes in the body that when you take in a substance, such a substance undergoes some metabolic processes and produces, some products, some metabolites. And some of those metabolites could be toxic. And you do refer to such as endobiotics. So such as substances like hormones, which are being secreted by different glands, neurotransmitters, and even in the process of metabolism, some byproducts which are produced. These are all endobiotics because they are produced by the living organism itself in the body. But another thing we need to pay attention to is the fact that something is a xenobiotic does not necessarily mean that that substance is toxic. Because of course we have established that toxicity depends on exposure, dose, the amount of the substance to which you are exposed, and even within the context in which you are exposed, which will even come to the more. And there is this misconception that synthetic substances are more toxic than natural. Such a misconception you find even in some advertisements, and like among us in the society, you do hear things about now that a lot of talk about these herbal products here and there. People talk of it as if because herbal products are coming from natural plant source, they are less toxic than synthetic medications. That is a misconception, because now you know that there are many highly toxic substances that are from natural sources. Because we did see, even from our first lecture, that there are substances from plant sources that were toxic, highly toxic, as well as from animal sources, bacterial sources, like the botulinum toxin. These substances are from natural sources, and they are very toxic. So it's not it's not true. It's not a fact that because you are taking in a substance which is from a natural source like a plant source, and because of that, that substance is less toxic than if you are taking in a synthetical, a synthetic substance, a medication to manage a particular condition. In fact, there are many times that many of these, um, herbal products actually that are not fully studied uh, can cause many more problems than just having a synthetic medication, which has been more studied and is, sort of the substance, the active ingredient in it is more of a pure form with some excipients added, and you take in that is sort of simpler and solves your problem for you much more than going in for a mixture of things, different concentrations which are not determined, and some of these can even go and cause more toxic effects for organs like the liver, the kidneys, especially for old people that their organs, are less, effective because, with age, you have the performance of these organs also reducing. So it's of a concern that, I mean, if you are a knowledgeable person, and particularly if you have some old persons around, I mean, some of these things you should be able to educate them about it. I mean, I remember, I think there was some few weeks ago, or maybe a month or more, one of my old men in the village sent me some WhatsApp, message of somebody talking about the use of Gary as some kind of treatment for so many kinds of disease conditions. From diabetic conditions to uh, stomach ulcer, heart conditions, so many things, cancer, that Gary can solve all these problems for you. And I mean, after listening to the video, I just sent him a message. First of all, reminding him, because he knows me well, so I reminded him that I'm a serious scientist. So I told him that a lot of these things are resulting into, preventable deaths in the society. Even though a lot of knowledge abounds these days, people still stick to some of these anecdotes, and they go about taking all sorts of things inside. So I admonished him, please, if you are sick, please just see a specialist, go to the hospital, get diagnosed, and be given a, proper prescription, proper care. At least, yeah, he thanked me for that, and I know that obviously he's not going to follow such a thing, that if he's feeling somehow, because he's an old person, so he just goes and says that, oh, because he heard somebody record some the thing audio and start posting, and people are flying it all over on the WhatsApp platforms that Gary can solve problems, and so every time you'll be sick, then you go and do a bar and be eating and think that you are solving your diabetic problem. When you know that, I mean, what is the source of Gary? Is coming from cassava, and cassava is a root tuber. So what at all it is in Gary? I mean, most of it is starch, carbohydrates, and someone is having a diabetic condition and will be consuming more of it. I mean, that is death. Right. Now, even with that xenobiotic that we are talking about to say that these are substances coming from external sources. And then we even talk of the fact that you have some substances that are produced, endogenously. We did refer to some of these, like the hormones and neurotransmitters and things like that. But currently, with modern understanding of toxicology, we do know that there are some substances that we refer to as xenobiotics. Let's say, for instance, this substance, acrolein, which is a chemical substance, I mean, it's synthetic, which is used, in many industries, like in plastics production, for instance, it's used. And so it's been known to be an exogenous substance, toxic, that, can cause some problems for the central nervous system, problems like, in Alzheimer's disease, some dementia it has some of these effects there. But, with the current analytical instrumentation that is available, that we are able to measure or say detect or analyze substances in biological fluids like blood, urine, saliva, synovial fluid. I mean, all these biological fluids that you can think about, or say biological tissues, that we can measure, we can analyze substances at even very low concentration levels, so we can have detection of these substances. It's currently known that acrolein, for instance, can, it can be produced internally in the body itself. I mean, by metabolic processes, except that the amount of which is produced in the body is very minute, that it will not be resulting into any toxic effect. So in such a case, that substance which we have known to be a xenobiotic coming from an external source, but the substance can also be synthesized in the body, I mean, through metabolic processes. How do we classify such a substance? Do we say it is still a xenobiotic because it is from the external source that you have the substance in large amounts getting into the body? Or we say it is endogenous because it can be synthesized in the body? Or do we say it's both exogenous and endogenous? So these are some questions about this kind of classification of substances as xenobiotics or endobiotics. Because of course, yes, acrolein, for instance, apart from industries, even in your kitchen, when you are preparing food, some preparation, especially when you are doing a lot of deep frying in an enclosed place, that not so much of ventilation, you can have the production of acrolein coming from such a process. Acrolein can be coming from a lot of combustion from, say, engines, vehicles, fires like forest fires, from tobacco smokes. Acrolein can be produced in the environment by all these processes, that when a person is exposed to it, the cumulative exposure of that later in life, in old age, has been found that these can result into some dementia. So the use of the word xenobiotic, endobiotic also has this dilemma around it. But of course, if you are knowledgeable about toxicology, because now you are doing toxicology, so you are getting knowledgeable about it. Then, of course, when you use the word xenobiotic, you will understand that, yes, even though it refers to substances that are coming from external sources, you do also have even some of these xenobiotics that can be synthesized in the body. I mean, simple things like, for instance, let's say methanol, for instance. In metabolic processes, you can have methanol produced in the body in some little amounts. Even though we do refer to it as a xenobiotic coming from external source, that can be toxic to the body. Now, another term is toxicant. It's also a common term. And what does it mean to say a toxicant? I think toxicant. It's not that commonly used in, say, in common language, except among persons with scientific knowledge. We use toxicant because a lot of times you hear in common language, even people not in scientific circle will be using words like poison, toxin, but you rarely hear any of such persons use the word toxicant. And a toxicant, yes, is any substance that has the potential of causing harm. You refer to, say, the cell or the tissue. But of course, even when you say cell or tissue, obviously, an organ is made up of tissue. So if you have such a toxicant affecting some cells or some tissues, obviously that effect is in an organ also as well. And so in this case, what it means is that what you are referring to as a toxin, which is coming from a natural source, is also a toxicant. So I think I made a comment before that toxins are toxicants, but not all toxicants are toxins. Because now you know that toxins are those substances that specifically come from natural living sources. So yes, it's coming from a natural living source and it can be harmful to the body, has that potential of causing damage to cells and to tissues. So it's a toxicant, but there are other toxicants that are not coming from natural origin, but are coming from synthetic origin. So these, when you think of it in terms of, in the context of exposure, the exposure to these substances can be deliberate, or maybe there's some kind of an accident, maybe in an industry, or it just happens that it's not an accident per se, but it's an unintentional exposure to these substances. So an accident will be, say, there's an incident that occurs at a workplace. That's an accident. But if, for instance, due to the normal operations of an industry, the industry releases a certain toxic substance at a certain level over a certain period of time, that's not an accident, but it is unintentional that a person will get exposed to such a substance. And the word toxicant is also used, with different prefixes to specify the specific organs on which the substance can have some toxic effect. Of course, we'll come to these things much more later, and we'll get to see the specificity of toxic effects referring to the target organs. So, for instance, we'll hear things like hepatotoxicant, which means the effect of such a substance is specifically on the liver, or you hear hepatotoxicity, so the effect on the liver, or you hear, say, nephrotoxicity or nephrotoxicant, nephrotoxicant, meaning the substance is having effect on the kidney as a target organ. Now, we move on to take a look at another concept, which is to do with different cases or different scenarios of chemical exposure. And we can classify this into four different scenarios of chemical exposure. The first one is what we refer to as acute exposure. An acute exposure, it's an exposure to chemical substances within a period of a day. That is within 24 hours. That there is an exposure to a substance, and it begins to within that period already the toxic effect manifests. That is an emergency situation. That's what we refer to as an acute exposure. So I mean, usually it is by some accidental, or maybe like some people also deliberately taking some poison, some toxic substance, ingesting high dose of it, and it results into an acute condition. And you notice symptoms of such acute exposure includes things like restlessness, irritability. It can cause some kind of delirium, say confusion in the person. Of course, some head turning, vomiting, diarrhea, convulsions, and it can result into fatality. A lot of acute conditions, do result into fatality because at such high doses, sometimes every effort which is made by the clinicians to remedy the situation may not be able to save the victim, and so it results to death. The next is a subacute exposure. That will have the toxic effect of the substance getting manifest, after several days to a month. So that's more than a day, all the way to even about a month before the toxic effect of the substance is getting manifested. But this is referred to, the subacute exposure is referred to particularly with persons that have no prior exposure. So it's not that the person should be having some exposure to the substance, and then just again within a period of some days to a month, when the person is exposed, then there is a manifestation of the toxic effect, and you classify that as subacute. No, the person shouldn't have any prior exposure to the substance. Because of course, the moment a person had some prior exposure, then it means that the exposure time, if you actually put it together, is more than, say, that period of, say, the number of days or the month that you are talking about. So it will fall into another form of a scenario. So this is for subacute, for several days up to, say, 1 month. The next, subchronic exposure. Subchronic exposure. So if you notice, you see that the periods are increasing from 1 day, which is within 24 hours as acute, then from some days to 1 month, that is subacute. Now we've come to subchronic, and subchronic is the situation where there is manifestation of toxic effect of a substance after 1 to 3 months of exposure. So the exposure time has increased. So from say a month to 3, if you have exposure to a substance resulting into some toxic effect manifestation, that is a subchronic exposure. And this can be some diet, maybe some, particularly when you travel somewhere, and within the first few months, the 1 to 3 months, maybe you are drinking a certain water over there, which is having some substance in it, and you are reacting to it. I mean, that is subchronic because you have been exposed to the substance for like, say, 1 to 3 months before you begin to show some signs of a toxic effect. So that is a subchronic exposure. Then chronic. So chronic is more than 3 months of exposure, and this can be over even very long period of time, like over a number of years, decades. And then before you start to see signs. So this will usually occur with some accumulation of the toxic substance over this long period of time before the toxic effect begins to manifest in a victim. So that is chronic. All right. Now done with these scenarios, we can also look at the toxic effect of substances in 2 ways. Substances such as these strong acids and bases do have some sort of corrosive effect, and these are substances that are exhibiting what we refer to as local toxicity. So local toxicity will be with direct contact with the substance. The substance, that substance has a direct contact, say maybe for instance with the skin, and immediately it causes some toxic effect like burning, for instance. Or you can think of the case of, say, tear gas. I mean, that is having some effect on the lacrimal glands, and you start tearing, and then you start feeling irritation in the eyes. And some of that, even tear gas also, can even cause irritation on the skin, for instance. Pepper sprays. I mean, those things have these, local toxicity because they are acting directly with contacts with a with a living system, and then it begins to cause some irritation, or even substances that when you breathe them in, it actually causes say direct irritation in the say the nasal cavity, for instance. Maybe you start to be sneezing, having some kind of irritation in your respiratory tract. These substances are having what we refer to as local toxicity. Now we juxtapose that against substances that have systemic toxicity. So a substance with a systemic toxicity means that the substance, first of all, maybe gets into the body by ingestion. And when it gets into the body by ingestion, the substance will get absorbed into the bloodstream. And then it flows to organs. So it starts having effect on, say, let's say a target organ like the brain, or a target organ like the liver. So this kind of toxicity is what is being referred to as a systemic toxicity, because it goes into the system, flows through bloodstream, and then goes to some target organs. And you can even talk of it of not just an organ, but an organ system. So for instance, if you refer to, say, the nervous system, or the central nervous system, the brain is part of the central nervous system. The spine is part of the central nervous system. Uh, if you talk about maybe cardiovascular system, the substance will have effect on the heart, and they even have effect on some other, maybe the capillaries, the veins can have effect, on all of these. So that is that distinction between local toxicity of a substance compared to um, systemic toxicity. Now we move on to another concept which we actually referred to the last time. When we mentioned Paracelsus, we did mention dose, which is to say the amount of a substance to which there is exposure. That is the dose. To say, so simply say the magnitude of exposure. That's a measure of a magnitude of exposure. What is the amount of substance that the body is exposed to? That's the dose. Now, we take different hypothetical situations. So these so the first one that I label graded dose response curve. That is a hypothetical exposure of say a victim to. So that's an individual that is getting exposed to a toxic substance, and that toxic substance has the toxic effect of causing cell death. Maybe some apoptotic effect. That is to say that it will induce cells to cause some cellular suicide, what we refer to as apoptosis, for instance. And you have the toxic substance, the concentration of it. As it increases, you have the percentage of cell death increase gradually up and gets to a point, 100%. And that is to say, at that point, all the cells die. Now, what you notice is that this, even though we'll come to the dose response curve even much, much more later and look at it much more in detail, but you see that in the toxic effect response to dosages, all these curves have this sigmoid shape, like the S shape. You will see that throughout, that they have this kind of a sigmoid curve. It's characteristic of substances taken in and having some toxic effect. When you even study it in terms of pharmacology, that you are looking at substances with medicinal or therapeutic effect, you also see such sigmoid curve. But here we're looking at it in terms of toxicity, and you're seeing similar sigmoid curve. Now, this relationship between the concentration of toxicant to the toxic effect of cell death in an individual, if we look at it in terms of say a population, that is the second, what we do refer to as a quantile dose response curve. You see a similar curve And the dose response is referring to the toxic effect of hepatotoxicity. That is the effect of the substance on the liver. So you are taking a certain group of people, a population, and you are looking at the effect of the substance on the liver, and you see there is a value we refer to as the TD50. You remember we saw the LD50, which is the uh, amount of the substance that results into 50%, I'll say an amount of the substance that causes toxic effect in 50% of, say, the number of laboratory animals, or the um, uh, the um, animals which are being used to do some tests. Then you have say 50% of the number of those animals. Like if you use 10 number of animals, you have in 5 of them you have such an effect, toxic effect. Okay, so Ajay Rejoice is saying that I'm not audible enough, which is strange because my microphone is maximum volume, so I don't know why. Maybe if you are using a phone, you may have to do settings on your phone to speaker and not the device itself. If you just allow the device, the voice will be low. So you have to check that setting on your phone, and you'll be able to hear me well. So you have TD50. This time around, TD50 is like a toxic dose, which means that dose is what will cause the toxic effect in 50% of the population that are being studied. Or let's say 50% of the toxic effect which is being caused is caused by a certain concentration of the toxic substance. Now there's another value you notice here, NOAEL, which refers to no observed adverse effect level. So if you notice, the curve actually starts, from the first, even starting from 0, you see those points which are like triangles. So you have a certain doses which are causing no toxic effect all the way until it gets to a point, then the curve begins to rise. So all these points at that no toxic effect is being noticed. That's what is being referred to as no observed adverse effect level. And so the curve begins to rise, and it means at that point you start to detect some toxic adverse effects from such a concentration, increasing all the way to the maximum. Now, the last one also, studies of, still well, you can say it's in an individual, or you can take it also as, say, in a population. That is, you can have these curves that is being that I've labeled multiple endpoint quantile data. In this hypothetical situation, you have different concentrations of toxicant that will result into different forms of toxic effect. So you see, you have at a certain concentration, you have the substance causing some skin irritation, some skin rashes can result. But at such low concentration, it is only the skin rash that results, but you don't have, say, liver damage occurring. The concentration will have to move much higher to begin to result into liver damage. Similarly, you have further increase in concentration of the substance, which will then be resulting into some central nervous system depression. So that is the same substance that at different concentrations, it will be having different toxic effects. Of course, what it means is that if you have the substance having, say, this, the highest of the concentrations that you have that can result into the central nervous system depression, then it means that all the other, two conditions before it, like the liver damage and the skin rash, will occur. But if you have the concentration being at just the level that causes skin rash, it means it is only skin rash that is good, that the substance will cause, but it will not be resulting into, say, a liver damage. It will take a much longer time for it to come to that. And if it is causing a liver damage, maybe it has not gotten to the concentration where it will be causing a central nervous system depression. But once it got into the level of liver damage causation, then of course it would have already caused skin rashes before coming to that level of causing liver damage. So these are some of the concepts related to the dose. We'll continue to take a look at another concept of say we take different substances. So let's say we take different toxicants A, B, and C, and these different toxicants are having some toxic effect of causing bladder tumors, causing some bladder cancer. So you have this carcinogen, these carcinogens, A, B, C. If you take a look at a curve of A and you compare it to B, you notice that A and B can reach up to 100% of causing the bladder tumors. A and B can reach that. But you see that a lesser amount of A will result into the causation of the bladder tumor than B. And of course, than C. So what it means is that A is more potent than B and C, because a lesser amount of A will cause that effect of the bladder tumors. You have to take more amount of B and C to also cause such bladder tumors. So A is more potent than B and C. So that is the concept of potency. How about if we talk about efficacy? That's efficacy. So if you take a look at substance A and B, they have reached up to, say, 100% of toxic effect. But substance C reaches just about 50%. So if we compare substance C to B, you see both B and C are having the same potency, because it is at the same concentration that they begin to cause the toxic effect, but C has a lesser toxic effect than B and A. And so C is having less efficacy than A and B. But C is having the same potency as B. So these are also some concepts that you want to keep. Now we can move on and go to what we do refer to as some unexpected toxicant sensitivity. You see, when we study the effect of substances uh, on a population, so we do an assumption that there is a normal distribution. Like, say, when we say a normal distribution, what we mean is that the population is homogeneous. Like, everybody is responding to the substance in the same way, same manner. And if you do such a normal distribution, yes, fine, you'll find that you have a certain dose of the substance, a certain median dose of the substance, which is the 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 concentration or the dose at which you have the highest number of response to the substance, the toxic effect to the substance, in order to set say permissible limits of such a substance, that persons should not be exposed to a certain limit, because when you do such population studies, you realize that it is at that concentration level that you have uh, more of the population responding to the substance. Of course, even with such normal, what you do refer to as a Gaussian distribution, you have some outliers that you have lesser number of people that also respond even at lower concentrations. So which will mean that if you want to set like uh, lower limits, you'll be setting them at such level that even the smallest number of people are responding to it, because it is from there that you notice that people begin to respond. People begin to have such toxic effects. And so you want to have the lowest amount set as a permissible limit to protect the population from getting affected. But that is if you are thinking of the population as a homogeneous population. Everybody is going to fall within this. But in real life, that is not the case. You do have, you see, that's why I said it's not every time when you do some uh, research and you have some result and you have things written nicely that it is actually really nice like that. In real life, things can be different for some people. So you have in certain cases some people that have very, very sensitivity to substances, which at the time of the maybe clinical trials that are being done on these substances, those unexpected sensitivity have not been noticed. And it is only when a substance is already being used over some period of time that you notice that there are some vulnerable people. So it's a vulnerable subpopulation that even at lower than the limits that have been set, those people are having some really high sensitivity at very, very low concentrations. These are some rare situations that occur. They are unexpected, and they do occur. And they don't fall within that normal distribution, which has been used to set the limit. Now you see that is being represented there. You have some vulnerable, subpopulation, which is not conforming to that normal distribution, which we saw much earlier. And so you see, when you look at the dose response curve here, you see that even at such low concentrations, you have such vulnerable population exhibiting some significant uh, toxic effects, even as such. But if you go back and look at, the curve for the normal distribution, you notice that at this point, you have, that curve uh, still at, what we did see as a no observed adverse effect level. But that's no observed adverse effect level in such vulnerable subpopulation becomes actually a significant observed level in such subpopulation. So you can have such unexpected toxicant sensitivity, which is a non-Gaussian distribution. It's not, so what we say the Gaussian distribution, you have such a bell shape, but when you come to the non-Gaussian distribution, you see that this is not a bell shape because you have the vulnerable population also having, significant response, even at very low doses. Now, we can move on from there. Now, we can look at what we refer to as some idiosyncratic toxicities. So, this is what you see in some individuals that have some sort of impairment. It can be, genetic. So I am using, some, a particular case of ethanol metabolism to express this. So that you have, ethanol undergoes oxidation. I think we've looked at this metabolic process when we were looking at, when we were studying enzymology in general biochemistry. I did talk about it, that you have ethanol undergoing metabolism to acetaldehyde under the activity of this alcohol dehydrogenase, and acetaldehyde is further converted to acetic acid, and this is happening in the mitochondria under the activity of acetaldehyde dehydrogenase. So these are two enzymes. The first enzyme is alcohol dehydrogenase, the ADH, alcohol dehydrogenase, oxidizing ethanol to acetaldehyde. Then acetaldehyde dehydrogenase catalyzes the oxidation of acetaldehyde to acetic acid. Of course, this is a common metabolic pathway for alcohols in the human system. Of course, similar reaction is in other organisms as well, and this is occurring in the liver. Now, and you see, acetaldehyde, has some toxic effects. That's an aldehyde, has some toxic effects. It is actually what is responsible for what is commonly referred to as hangover. When people drink too much and the amount of alcohol that is being metabolized to acetic acid, that the rate of the reaction is lower than the amount of the ethanol which is being taken in, which means that at a point acetaldehyde will be accumulated in the body, and that such acetaldehyde accumulation is what results into some headaches and loss of orientation and things like that in such heavy drinkers. But see, the metabolic system is such that the acetaldehyde dehydrogenase is able to convert that acetaldehyde quickly to acetic acid. And then that acetic acid, of course, can just go into, say, formation of acetyl-CoA and go to the Krebs cycle and just generate energy. But in some individuals with some genetic, polymorphism or some genetic abnormalities, they lack that the aldehyde dehydrogenase, or the aldehyde dehydrogenase activity is much lower. So these are persons that usually they are referred to as, say, slow metabolizers. And so in such persons, you have an accumulation of this acetaldehyde, which can result into toxicity. I mean, which is why you can have maybe some group of people that are, like, say, drinking the same number of, the same amount of, say, alcohol, but you have a certain, group of people that will experience nothing. Everything will be okay with them. But you have some group of people that when they take, that same amount of the alcohol, they experience serious toxic effects. And this even happens, with some populations, like maybe some Asian populations, for instance, have this kind of differences in the metabolism of alcohol, for instance. And so you can see that on the right-hand side, where we are looking at the let's say the blood concentration levels, for normal persons. So which is the thick curve, which is showing ethanol that is taken in. So that's ethanol taken in by, such, persons with aldehyde dehydrogenase that can break down acetaldehyde quickly to acetic acid. You see that curve, the very faint curve, the third one below, the last one below, is showing for normal persons how acetaldehyde levels is low, and you have the acetaldehyde lowered all the way quickly. But for the acetaldehyde mutants, so in persons, I mentioned that you have some genetic polymorphism. People have, some, the genes are having some slight differences, some mutations in for some people, that their enzyme, the aldehyde dehydrogenase, the rate at which it works is much slower, and so such persons are slow metabolizers. You see that the amount of acetaldehyde is higher, is much higher up there for such persons. So which means, the period of time that acetaldehyde stays in the system of such persons, the slow metabolizers, is much longer. Because see, the horizontal axis is showing the time after alcohol consumption, and you realize that if you have this, the straight line there, which is showing the threshold for acetaldehyde toxicity, you see that for such persons that have this slow metabolism of alcohol, acetaldehyde stays much longer in their body above, the threshold acetaldehyde toxicity level up there. I mean, this is for just alcohol, but even in cases of some medications, you have such an effect for this polymorphism of some genes, which are responsible for coding for some proteins, which become some metabolic enzymes, some enzymes that are responsible for the metabolism of certain drugs. And in fact, this goes into a field that is referred to as personalized medicine, so that dosages are actually determined for individuals. They are customized for individuals and not just dosage for everyone that is given. I think I spoke about this when we were doing general biochemistry. All right. Now, with that, we can move on to cases of hypersensitivity, which we can refer to also in two ways. One of them is the allergic toxicities, which is something which is related to the immune system. So the toxic effects, will result into some activation of an immune system. And you can have such, hypersensitivity, toxicities being caused by, some drugs, medications like penicillin. Penicillin and all of these drugs in the class, referred to as the beta lactams, which are let's say the penicillin class of antibiotics, the beta lactams, like amoxicillin, amoxiclav, clavulanic acid, all of these are beta lactams, which are known to, cause some allergic responses in some individuals. And those responses are unrelated to like the pharmacological action of the drug itself. And I mean, what has been, what is the reason? What is the cause of such hypersensitivity that these substances are inducing? It's something which is still being studied, and there are two different proposals to this, but each of them still not so much clear for all the substances. For instance, one of the proposed mechanisms of this hypersensitivity toxicity is by what is being referred to as haptenization. And that is it's a phenomenon that describes, say, metabolites that are produced from a substance. So a substance undergoes metabolism. A product is formed, which is a metabolite, and that metabolite is reactive. And so, I mean, reactive in the sense that it can bind to some proteins, particularly some immunoglobulins, which are some immune cells. And so these form what is being referred to as some neoantigens. I mean, you have I mean, in the system, the organism's own antigens that will trigger, some immune responses. But now you have these metabolites that bind to some self-proteins, and they act as some other forms of antigens that now trigger some kind of adaptive immune responses, like some kind of some autoimmune responses. And such then results into, such a hypersensitivity to the substances. So it's not the substances themselves. I mean, with this explanation, with haptenization, not the substances themselves that are causing that adaptive immune response, but it is their reactive metabolites that are binding to some proteins, which then form some neoantigens to trigger such adaptive responses. Now, another proposal is that you have these reactive metabolites themselves causing the hypersensitivity, which is referred to as bioactivation. And And this bioactivation, you can also look at it as, what is referred to as, let's say, toxication or toxification. The the uh, main purpose for metabolism of drug substances, or let's say any of these xenobiotics that get into the body, the main purpose of, say, the liver having a biotransformation of that substance is to detoxify the substance, make the substance less toxic, and get it excreted out of the body so it doesn't have any toxic effect on the body. But as it is, you can have this process, which is bioactivation, which is rather causing some toxicity. So you have toxification rather than detoxification. So that is what it means. You have a reactive metabolites that are resulting into some, hypersensitivity. But of course, as I said from the beginning, that you have these things still not fully understood, even though you have these proposals. You see there's still some puzzles that are being studied. So, for instance, if we are talking about uh, either haptenization or bioactivation, that you are referring to reactive metabolites. But you see, the metabolic pathways of the substances are broadly the same, similar, for all individuals. And yet you have just a handful of these persons exhibiting hypersensitivity, but the majority of the persons that are exposed to these substances don't have any sensitivity to these things. So which means that we can't explain the hypersensitivity just by the metabolic pathway alone. Because if it is only by metabolic pathway, then of course, such a hypersensitivity should be occurring in every person, because the reactive metabolites are formed in all the persons. And yet, it is only a handful of these persons that you have some hypersensitivity occurring. Well, if you also look at it in terms of, say, which parts of the body do you really see, most of the times, these, hypersensitive responses? Mostly you see these things like, say, maybe in the skin, for instance. So have people responding with some skin rashes, pigmentation, things like that. And of course, that is because in the skin, you have less amount of metabolic enzymes in there. If you take the organ, the liver, that is where a lot of these metabolic enzymes are packed. And so perhaps because you have less amount of enzymes in the skin, so that you don't have these enzymes that can act on these reactive metabolites, and so they accumulate and they begin to have such effects. Now, even if you think of it that way, everybody has a skin, and so the substance will obviously go into the skin of everyone if it is that, like, it's flowing in the bloodstream and gets to the skin. But not everybody experiences the same hypersensitivity. So these are areas that are still under study, not really fully understood. Well, we can move on and then also take a look at toxicant-toxicant interactions. So if you have maybe two or more toxicants that a person is exposed to, how do these, the combination of these toxicants, the effect of it, what happens with these things? When we're looking at 4 different cases, 4 different scenarios of these toxicant-toxicant interactions. Now, the first one is what we refer to as additivity. So we have toxicant A and toxicant B having the same level of toxicity. The same level of toxicity, or let's say the severity of toxicity with toxicant A is equal to the same severity of toxicity for toxicant B. Now, when the two of them are present, when there is exposure to the two of them, the toxic effect that is felt for the two of them concurrently is the sum of the toxic effects of A alone and B alone. So that's why we have here 2 plus 2. So for instance, it's equal to 4. So it means the effect you feel for A is added to the effect that is felt for B. That becomes, the toxic effect when you have A and B concurrently being exposed to. And that is what is referred to as additivity, sometimes also referred to as summation effect. We move and look at what is synergistic effect, synergy. So it's a term which is referred to a lot of times, sometimes misused, but you have to fully understand it, what really it means. Because sometimes I do see students, coming to defend some project works, and a lot of these, students who do this, maybe they do some extraction of some plant, and then they do some microbiological analysis on some microorganism, some bacteria, and then they are talking about synergistic effects of, say, maybe some 2 or 3 substances, which perhaps even what they are talking about is not when you look at it critically, you are not able to tell if really what it is they have is synergy. It's a synergy effect, or it is additivity. If it is, well, we'll continue and see the other two as we continue. Of course, if it is the case that if you take 2 substances, the effect of these substances are much, much higher than their sum, then you can say that you are having a synergistic effect. So for instance, here you see that toxicant A is having a severity of toxicity of, say, around 1 unit. Toxicant B is also having the same 1 unit. But the two of them together concurrently is giving you a very high, severity of toxicity, more than just the addition of the severity of the two. And so you see, that's what is being written there. 1 plus 1 is equal to 5. Because you can see the toxic effects of the 2 toxicants separately are very low, but when the 2 of them are put together, the toxic effect is very, very high, higher than the sum of the toxic effects of the 2. So that is synergy or synergistic effect. How about potentiation? So the next is potentiation. And you see potentiation, you have toxicant A is having 0 severity of toxicity. In other words, it is non-toxic. It has no toxic effect. Or let's say, because we are speaking about a particular, let's say you're speaking about a particular toxic effect, in such a case, that toxicant A is not having such a toxic effect. It may have another toxic effect, because we are now talking much more as specialists in toxicology. So we know that substances may not be toxic in a certain sense, but in some other sense it may be toxic. So in this particular case, you see that the toxicant A is not having some particular toxic effects. And you have substance B is having, severity of toxicity of, say, around 2. Now, when you put substance A, the toxicant A and toxicant B together, this gives you a high toxic effect up to 5, which is to say that even though toxicant A itself exhibits 0 severity of toxicity, it gives some potentiation. It increases the toxic effect of toxicant B. That's why you see that the level of severity of toxicity has increased. So that is potentiation. Now, the opposite of that, well, not really opposite per se, but because if you look at the antagonistic effect or antagonism, the representation here does not show that any of the substances is having a 0 toxic effect, but that can also be a scenario, so that you have antagonism. You see toxicant A is having a certain toxic level, and toxicant B is having a lower toxic level. When you put the two of them together, the toxic level even reduces much lower than the toxic levels of the two separately. That is antagonistic effect or antagonism. So we can say toxicant B actually antagonizes toxicant A, so that the toxic effect of toxicant A is lowered. I mean, that's what I was saying from the beginning. You can be that maybe toxicant B is having a 0 toxic effect, but when it is added to toxicant A, it then results into even much lower, toxic effects. That can also be a scenario for antagonism. It only means that when you put 2 of the toxicants together, the toxic effect of the 2 together is much lower than the toxic effect of the 2 separately. That is antagonistic effect or antagonism. All right. So these are major toxicant interaction concepts that you want to get well. Now we can talk about some lifestyle determinants of toxic susceptibility. In fact, many toxic effects depend on lifestyle. A lot of conditions that in the past generally just referred to as consumption conditions, and particularly with diet, kind of food that we take in will have some effect on some toxic susceptibility because of the content of these foods. I mean, people take in a lot of maybe say a lot of these smoked barbecue, plenty all the time. It's like some kind of a dietary habit that a person is just consuming these things every time, and even the time, maybe consuming these things at an odd time, late at night, and all of this, can result into some accumulation of some metabolites and that can result into some toxic effects. We also know from our biochemistry that, sleep habits, sleep conditions have effects on the immune system. And so you can have, the habit of, how you sleep. Do you sleep well? I mean, do you sleep enough? I think a lot of times, many of us just run around the whole place, whatever it is we are looking for in this life. We don't have any proper sleep and all of that, and we break down our immune system's not so strong and things like that, and we begin to have susceptibility to many things, including, toxic susceptibility. The kind of work we do. So, of course, if you are working in a university like me, in a biochemistry lab, in a chemistry lab, you are or microbiology lab, you are exposed to chemicals, you are exposed to microorganisms. Somebody working in some mines, or is working with some radiations, X-rays, and things like that. So your occupation makes you get exposed to certain things. I think the last time we did talk about industrial, toxicology, and we even spoke about the fact that the workplace can be a source of, exposure to toxic substances, which has resulted into even the passing of some laws to protect labor. Workers having some insurances for these things. Smoking, the use and excessive drinking of alcohol. All of these can increase susceptibility. Toxic susceptibility to substances. Because of course, for instance, smoke that cigarette smoke, which will go already have some inflammation to the lungs. And there's a lot of knowledge that abounds on the cause of, say, lung cancer and different forms of cancer coming from, the content of smoke. Tobacco smoke, and the different kinds of smoke. These days, you have these things in Ghana now. We say what shisha and things, and people, make some kind of statements. Those ones are better than cigarettes. And no, what is it that you are smoking? Is it not tobacco? And even if even those ones, apart from tobacco, they add some flavors and things, those chemicals and things like that. All of these things contain some toxicants, and they are going to have some serious toxic effects, on the system. All right, now, so in fact, a lot of things, like I said from the beginning, even though, yes, there are, genetic predisposition to some of these things, many of these things, but many also depend on our lifestyle. How we live, has a big role to play to the manifestation of the effects. You do remember, the story of the ginger jake, the persons who adulterated, the ginger drink in the US, and it resulted into some neurotoxicity in some consumers. We are moving to another concept of latency. That is referring to the timing of toxicity. Latency refers to, say, the time from exposure to the time of manifestation of the toxic effects. That's a latency period. And these can vary widely depending on the substances, the toxic substances to which victims are exposed to. So in the case of, for instance, that substance, the TOCP, which was used to adulterate the gingerjake, we had a latency period of about 7 to 10 days. So after victims drank this gingerjake, it's only after a week that they begin to have manifestation of the effect. So that's a latency period of such a toxicant. Now, 7 to 10 days is a short time, per se, 1 week, but you have carcinogens that will have much, much longer times, where you have substances that can accumulate for many years, decades, before they have their toxic effects being manifested. These are having really long latency periods. So for instance, smoking related cancers have such long latency periods where the onset of the manifestation of the toxic effects will be after some decades, 10 years, 20 years, before they begin to get manifest. That is tobacco. Again, one of the things which happen, I think the last time we did talk a lot about some of these occurrences in the past where people got exposed to many substances. I bring you one example again from the 1950s, the same period. There was this drug, diethylstilbestrol, which was some synthetic estrogen, which was prescribed for pregnant women, and it was for to deal with miscarriages and some other complications at the time. And it was known not to be toxic to the pregnant women. And they were taking it. Only after a decade that it was found out, so in the 1970s, it was found out that the offsprings, the babies, which were, in the womb of their mothers at the time that they were taking that drug, the diethylstilbestrol, particularly in the period of 1 to 5 months of pregnancy, that these, their mothers took these medicines. These children, the offsprings, later in their teenage ages, began to develop the females began to develop some vaginal cancer, some adenocarcinoma. So it's a reproductive cancer that they developed. And even the mothers themselves, later, even though at the time they were taking the medicine, it was not toxic to them, later in their old age, they were at higher risk of developing breast cancer. And the female offsprings, rather, now even developed things like ectopic pregnancy, if they got pregnant. What is ectopic pregnancy? The implantation of the fetus, not in the womb, not in the uterus, but rather in some other region, usually maybe in the fallopian tube. So it means you have fertilization, and instead of that fertilized fetus getting implanted in the uterus, it rather gets implanted somewhere in the fallopian tube. So they were having all these sort of reproductive complications, cancers, and even in the male children, they also develop some urinary tract, toxicity, developing some tumors also in their urinary tract. All right, so I think this is where I'll end with that, some historical account again, and then I keep quiet, and I also learn from your experiences, the things you can share with us in the class. All right, so I see Akbelu Christopher, your hand is up. Your microphone is allowed. You can speak, and I respond. I'll try to answer. If I cannot answer, maybe I will guide you on how to find the answer. All right, the floor is open. Christopher, your microphone is allowed. You can unmute yourself and speak.
Hello?
Yes, I can hear you.
Thank you very much. So I raised my hand because you were at the point of explaining the misconceptions. You pointed
Okay.
out that the traditional medicine, medicine from plants and in fact the natural ones, Your
Okay.
concern was that if we want proper treatment, we should go to the hospital. Now,
You must first be diagnosed. That's what I meant.
Okay, very well, very well. In the previous lesson, when you were talking about it, you said in the earlier times, our forebears.
You say when I was talking about what?
When we're explaining toxicity,
Okay.
you made us aware that if, for example, you were having a sting from scorpion or snake, there are traditional ways you could easily get out of those toxins using plant-based sources and animal-based sources. You made specifically of palm oil in some cases, and I understood it very well those days. I want to find out what is it in our traditional-based medicines that you think are not good enough that we should always follow the orthodox. I mean, personally, as a person, I like depending on the herbs. If they are not good, what can we do to make it very healthy for us? Thank you.
Okay, thank you very much for the question. So, what I mean about being cautious about the use of these substances, I mean herbal products, is to say that the substances have to be well researched, well understood how they act. That's all I mean by that. I don't mean to say that those substances are not good. No, that's not what I mean. So yes, after all, like you pointed out, in the past, yes, these herbs, these substances were being used to treat conditions, but you also have to appreciate the fact that it is from those times that we have built on the knowledge. And as there is that build of knowledge on what has been, things have been improved and become better and better. So if we have at a time that a substance is not, well researched, that you are sure of, we shouldn't be jumping up that is it. This is final, because you can also tell that from the historical accounts that we did refer to the last time that we saw. There were cases where even things were so much research and all of that, but they result into disasters. How much more something which is not which is not well studied. So it's just a word of caution. It's a word of caution that we should be cautious about it. That, I mean, the fact that something is from a natural source doesn't mean that the thing is non-toxic. After all, you have some countries have done well with the development of some of these their herbs. You know, for instance, like you see a lot of these Chinese herbs. Usually, they just take them like teas. Some of them, they have developed them into some food supplements, into some capsules, things like that. What we usually have in Ghana, yes, we also do have some capsules. I think we have some garlic capsules and some other things. And then what you should be concerned about is, some of these mixtures, which are, some kind of, I don't know, extraction from alcohol or things like that, some alcoholic extracts and things like that. It's a mixture of different things together. And you ask yourself, how much of, trials, clinical trials, and, much more, toxicological, analysis have been done, because before substances come out to be used, by populations, you need to actually be sure of, say, some long-term effects. That's why the development of medications can take a long time, like, say, over a decade, before something really can come out, before it's approved. So also, let's appreciate the fact that we have, some weak regulation problem. So we should be careful about this. So, Christopher, that's what I meant. It's not that I'm saying that it's bad and you shouldn't even think of it, but just be cautious. All right, so Augustine Kwache, your microphone is allowed. You can unmute yourself and speak.
Hello, sir.
Yes, I can hear you.
During the time you were differentiating between toxins and poisons, I realized that you said for the toxins, they are from natural sources.
Yes.
The poisons are from whether anthropogenic or artificial sources, if I stand corrected. But then, so I realized that growing up, they tend to, for the
Your voice is breaking, so not everything you are saying can be heard.
Hello, sir.
Yes, you can speak.
Okay. So, sir, I said when you were differentiating between the toxins and then the poisons, you said for the toxins, they are from natural sources.
Mm-hmm.
And then the poisons are from artificial or anthropogenic sources. But then I want to ask, during some of these documentaries, and some of these ecologists or biologists, they tend to say things like, this frog is poisonous, or this animal is poisonous. I want to ask, what should be the right terminology for that?
Okay, so the differentiation is not between the word poison and toxin. That's I made a differentiation between toxin and toxicant, which is to say that toxins are from natural sources, but a toxicant can either be from a natural source or from a synthetic source, which means a toxin is a toxicant, but not all toxicants are toxins. So that is to clarify that. Now, coming to the documentaries that you talked about, that some organisms are referred to as poisonous. That's English language. Yes, the organism is poisonous. What makes the organism poisonous? the toxins that it produces. So it isn't that the term which is being used as an organism is poisonous, is wrong. No. The only thing we have to understand is that when we say poison, in the modern concern about it is that it makes it look like there are substances which are poisons and there are substances which are non-poisons. But with our understanding now, we know that you can't really differentiate substances like that, that one is like some substances are poisons and some substances are non-poisons, because we know that the toxicity of the substance, depends on dose and even, within context of exposure. So it's just a discussion of the issue to understand these terms, and when you use them, you know that there are some limitations to the use of them. So that's what I meant by the the use of the word poison, and then toxin with toxicant. So I hope you get a discussion in that sense.
Yes, sir. Thank you.
All right. I think we still have like some 10 minutes more. Yes, I was asking a question from the beginning that do we have evening students with us? Because I wanted to be sure that the evening students are in the class. And if you are evening student, write yes in the chat. But in the beginning, nobody wrote anything in the chat. So I want to confirm that. If you are an evening student, write yes. Okay, let me ask. Christopher, either who is a class rep here? Maybe Emmanuel or class rep. Kindly raise your hand so that I can unmute your microphone. Okay, Emmanuel is here. Emmanuel, your microphone has been enabled, so you can unmute and speak.
Okay, sir, I'm unmuted.
Okay.
I'm unmuted.
So, all right. So I don't know if you can help me understand this. I noticed from the beginning of the semester, I have not had any contact with any evening students. No one has written me. No one has called me. And it appears it's only you, the weekend students, that I